Hello everyone, welcome to PMAC1114 Trigonometry. I am Professor Nguyen. You can call me Mr. Nguyen or you can call me Professor Nguyen. I've been with the school for a pretty long time, not really that long, but at least like 4 or 5 years already. And actually been around Central Florida. I've been with other college also, but I'm here with this college full-time professor. And before we start our first video in our first section, let me introduce a little bit about myself. Actually, in the announcement, I hope everybody will read the announcement. Read the announcement. I don't know if I say anything about myself or not, but please watch the read the announcement, the welcome letter in the announcement. That's what I recommend you to check all the time, every day. And I'm sure you guys already read the syllabus also, right? Um, so yeah, you read the syllabus and you check the announcement and an email, especially a Canvas message every day. 3 or 4 times per day to make sure that you're not missing anything, because the Canvas message is the only way and the best way for me to communicate with you. Well, you can send me a message through email, but sometimes your email falling behind, so I don't want to miss your email. So the best way is to communicate with me through Canvas inbox. Okay, and regarding to myself, um, well, I said, I've been with the school for several years, and I've been teaching math. Not, I mean, I can teach physics too, but most of the time I focus on math, and I've been this with trigonometry for several times already. But this is the video, the the first online video for trigonometry I made to you. Most of the trigonometry class I made is the face-to-face one. I don't know if some of you already had a class with me before, but uh, this is the first online classes for trigonometry I have, and I made a decision to give you a very beautiful 4K video. Or this I compress it into at least 1080p so that everybody uh, can see that the resolution is very good. Okay, and I don't know. It's just a think about that. If the video is beautiful, right? I mean, it's motivate more to learn, right? That's what I think. So in this course, I'm going to introduce a series of video on trigonometry, and we start with the very basic concept. And well, actually, the math departments say that we are using the textbook, and if you notice that the textbook, it is say that pre-calculus. It's not a trigonometry one, but in the pre-calculus textbook we have trigonometry, and some of course some in the other school they use the whole textbook, trigonometry textbook, but I mean it doesn't matter. The trigonometry is still trigonometry. It doesn't matter as in a pre-calculus textbook or even it is a calculus textbook. Trigonometry is still trigonometry, and it's very important course, especially for those who have major in engineering, mathematics, physics, and for those who major in something else, I guess I hope that this is the only class you had to take. I don't. I hope that you don't have to go further than this. But whether or not you like it, you have to pass the class, right? That's all. You had to pass the class. And before we start the first video, again, I just want to say sorry. I have a very bad allergy, and sometimes I have to cough during the lecture video. So be patient with me on that part, okay? So the textbook we're using is Leon Hornsby Pre-Calculus by Leon Hornsby. It's 7th edition, pretty big and thick book. It's kind of very expensive too, but you don't have to buy the whole textbook. I mean, I recommend you to buy it, but the most important thing that you need to buy um, the the access code to do homework, because all homework be on the platform, my MATLAB platform. So you must have the access to the homework to do homework. Okay. I still recommend you to buy the textbook. You don't need to buy the new version. You can buy you can buy the old one. And sometimes it's cheap. You can get it from eBay. You can get a used one, or you can get even you get a brand new one in eBay, and it's sometimes it's cheap too. Well, get the book, guys. I mean, and nowadays people don't read book anymore because because you think that we have the ebook and you can access the ebook, but I think the physical book is still good. It help you. Okay, let's say you stuck in a problem, just open the book and see how they solve it. So so yes, I recommend you to buy the book. Just buy the used one will be fine, or the previous version of the book will be fine. Let's say this version is the 7th one, right? You can buy the 6th one or the 5th one. It kind of is the same. Yeah, it's very the same. They make money, guys, so they just publish a new one. They change a little bit, but basically it's the same. Okay, if you have any question, please contact me through Canvas inbox. Okay, and I will reply really fast. Believe me. I let my computer on this almost 24-hour days, so I try to reply really fast. And every time you send me a message, I'm sure that this goes through my email. So hopefully I'm not missing. So the trigonometry part in this textbook, we start with chapter 5, and you see that you look at the schedule. This is the schedule we have to go through, and these are all the topic, the concept we have to go through. So let's start with section 5.1. You see that, and 5.1, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have 23, 22, 23, 24, 25, 26. So we have 26 sections. So on average, we have to go through, if it is face-to-face class, then usually we have to go through at least one section per day. I mean, we have 2 class per day, so one section per class. So, but this is video. So let's say I have a 28 section. It means you have 28 video. I don't know any other video is a long one. I have to split up, but on average, I try to make a video 1 hour and 15 minutes. Um, well, I hope that we don't have to do longer than that, right? Because believe me, if you have long video, or you watch a video for like 2 hours, nobody wants that, and you get distracted easily. So the first section we got about is section 5.1. Okay. Okay, so let's get started. Okay, before we talk about section 5.1, if I want to introduce what the angle is, some terminology, some definition you need to know before you go higher, before you understand further concept. Before we're doing that, I just want to do a quick recall, and I try to compare between trigonometry or the others branch in mathematics. You probably know, or you've been introduced before. For example, like, I don't know, you guys remember the geometry you learn in high school. What is geometry, guys? Anyone know what geometry? Geometry. We're gonna start from this term. How you understand this word? Metry. What does it mean? Metry? What is zero? Now you go ahead and look it up on Google, and they say to you the geo it means earth, and metry mean measure. Metry mean measure. This is mean measure. And geo mean earth. So they try to measure something belong to earth. And this concept we already learned in high school. We're not doing geometry here, but we're doing trigonometry. It's very similar because geometry and trigonometry is related to each other. So in trigonometry, we try to measure something, right? Because you see that we have this word also, they say metric mean measure, right? But trigonometry, what does it mean by this? I try, this is looking at it, try mean three, try mean three. Gonometry, I mean angle, three angle. Oh, what is we try to measure three angle? What shape is that? What geometric shape does have three angle? Is that a triangle, right? A triangle. So in trigonometry, we try to do try to measure. We try to solve the problem that related to uh, triangle. And there are different type of triangle. We'll talk about that later. Okay, but but because you see that geometry and trigonometry is related to each other, so we kind of do a quick recall on some entity, trigonometric entity. And the first entity I want to review is point. Point. So point is is a dot, right? It's point a dot. It represents some location, physical place. So and let's say I can say the point A. And point A is that there's a point A is a dot, and you draw a dot, and you have A. You can name anything you want. So point is the entity of geometry. It's also the entity of trigonometry because they're related to each other. And the second one is if you have 2 points and you connect them to each other, so we have a segment. We have segment, so we can say that. Now we can say that name A and B. So we have segment AB, and you notate the AB with a bar like that because the segment is so segment is they have the limit, right? They have the boundary at the end. They have the end points, right? They have 2 end points, and actually a segment is a part of something we call a line. And you see the overlay line. I draw the 2 arrows here, and I can name it as this line AB too. But between the difference between the segment and the line is you see that line we have 2 arrows. The segment doesn't have it, right? So this is line AB. Have a line AB. Then thinking about it, one of the end points of the line when we cut it, we truncate it, and we truncate it. So let's say that over here we truncate it. We don't want to extend it to the left when we start with A, and when we want to extend it to the right direction only. Okay, then this one we call that ray, and this is called ray AB. Ray AB. So that's a ray, line, a segment, and point. Well, these 4 entities very important because it helps us to create angle. Okay, so on the first part of our section 5.1 over here, okay, let's talk about that. Angle, the definition of angle. Then we're going to go through some special angle we will be discussing in this section, and then probably we're going to discussing about that in the further section later on throughout the whole semester. So what is angle? What is angle? Let me go ahead and draw the angle. Because angle is created by 2 rays. I have 2 rays. And these 2 rays over here have the same point. Okay, and let's say I'm gonna point A over here, and over here the B, and this is C. So I have 2 rays, ray B, ray A, C. So this is the angle. Okay, this is the angle. Okay, that's the angle. And the angle, it could be the small one, or it could be the big one. Okay, so it just created by 2 rays sharing the same point, this point A, and this point over something we call a vertex. So this is we call a vertex of an angle. Okay, so this we have a vertex, vertex A. Okay, and I'm gonna go ahead and put this angle, and I put it on the coordinate system. Okay, let me go ahead and put it on coordinate system. Okay, so this is our coordinate system. It's y-axis, right? and this is the origin, right? Let me go ahead and use different colors so that you can see. Let's see, I'm gonna go ahead and use what color over here? Maybe green, orange, maybe orange. Okay, so I'm gonna go ahead and I draw the angle, and I put it on the coordinate system, and I try to put it on the first quadrant. So this is first ray. Okay, let's say I'm gonna put this angle over here. Try to put this angle over here, and with different color. So this is B right here. This is this B. Okay, this is B, and I'm gonna call this A. Well, you could call it O, but you know A is at the origin, and I'm gonna this is C over here. So you see that I put this angle in the first quadrant of the coordinate system, and if you put in this position, okay, in this position where one of the side is in on the positive x-axis. Okay, this side right here, right? You see, you always put one of the side on the positive x-axis. This position we call the standard position. Standard position. Standard position. Okay, and the first ray over here, the ray AC over here, we call that the initial side of the angle. And this initial side is fixed. It's a fixed side. It means that it's not moving. So the ray AC is not moving. But the ray AB over here, we call that terminal side. Terminal side. And the terminal side, you can rotate it. You can rotate it, okay? You can rotate it. So you can rotate clockwise or counterclockwise. So think about an AC fix, and you just rotate, you rotate like that, or you rotate like this, AC rotated. Okay, clockwise, counterclockwise. Okay, so the terminal side is can be rotated, but the initial side must be fixed. Okay, now so this is I have an angle. I'm gonna call this angle. Okay, the notation for the angle is I'm gonna call the angle A. Okay, you have the angle A with a hat. So this is angle A. Angle A with a hat. Or if we can go ahead and use three different letters to name the angle to make sure that you make sure that the vertex letter it must be between the other letters. So you can call that angle BAC, or you can call that angle CAB. It's the same meaning, okay? But you cannot call this angle over here is ABC because you put the B letter in the middle, then it's become a different angle. It's not angle A anymore. In some textbook, they're not using the head. Sometimes they use like this. They write like this. This is called angle A. I don't like this notation. Most of the time I use the head like this. But I don't know. It depends. Some textbook use the head, some textbook do like this. Our textbook, they are not using either of them. So actually, in our textbook, they just make the letter bold. So they make the letter bold. It means that the angle. I don't even like that notation at all. So let's say that they want to talk about angle A, they do like this. They draw like this, the angle A, and they bold it. They bold it really bad. There you go, that's angle A. I mean, well, I try to recognize that guy, but on the test, if you guys go ahead and create your test, so most of the time I use the head or I use this one. Okay, I'm not gonna go ahead and bold it because I don't want you to get confused between angle and vector later on because we're gonna talk about a concept of vector and they bold the vector too. So try not to be confused between those things. And that's why I say that first section is you have to learn it carefully. The terminology, on the notation, the symbol. Make sure that you understand that. Okay, now get back to the terminal sign. As I say, I told you the terminal sign can move around, and if it move, okay, let me go ahead and draw it again over here. Let me go ahead and draw it again. This is fake. Okay, just gonna let you know this is fake. See right here, and let's say that the terminal side is moved like this. So let's say it's opening up to the left a little bit. Okay, you see that it moved from here to here, and when it move from here to here, you see that it go counterclockwise. And if you go counterclockwise, the angle BAC or CAB over here, the angle A is negative. Remember that, okay? If it move clockwise, I'm sorry, move counterclockwise, it become, I'm sorry, positive. I'm sorry, a little bit confused too. I mean positive, but for some reason I say that. Move it this way, then it's positive. So if we go move clockwise, it become negative. What does make sense? Maybe some student will like, okay, how come it move clockwise? Clockwise supposed to be positive, right? But it's not. It's not. Okay, so if it move like this, okay, let me go ahead and fix this. Okay, so this X over here. So let's say that again, they have a terminal, they have a fixed sign, the initial sign, always like that. A over here and the C over here. But instead of moving like this, they move down. So they move down. They move down. And this is B right here. I'm sorry for the noise in the background because that's my mother. And she's very old. She's like 77 already. And yeah. Yeah, we live in a small house because I live with my mother. My dad passed away already, and we stay with here so to take care. We take care of each other because we live in U.S. but we don't have a lot of relative. So only 4 people in my whole family. I have 2 kids. My wife, my sister. My sister already got married. They moved away. And I have 2 little kids. Should be patient with me on that because I hope I'm not missing your email. But I have 2 little kids. Only I have a very small baby with only 6 weeks, 6 weeks old, and the other is 2 years and a half, almost 3 now. So yeah, be patient with that. But that's all. That's all our family. So sometimes you probably hear the noise, okay, in the back, and my baby cry. So uh, hopefully it's not because I try to isolate myself doing video, but we live in a small house, so be patient with me, okay? So this one is moving this way. So this is clockwise. And if it's clockwise, then we have angle over here. Angle A will be negative. Negative. Okay. So the angle, just let you know, the angle could be positive, or it could be negative. This is one of the quantity that have positive and negative. Well, one of the other quantity that have positive and negative is velocity, distance, but that when you deal with physics. But think about it. When you deal with angle in the reality world application, we don't have negative angle, right? But this is math, guy. So we have positive and negative, but in the reality, when you do word problem, I mean, if your final answer is negative, it means something wrong. So be careful, okay? When you do the test and it turn out to be negative angle, then it means you are wrong, okay? Especially the word problem. Word problem, never negative angle. But a theoretical trigonometry problem, we still have positive and negative angle. Okay? All right, so we have positive and negative, and you see that the terminal side is opening up or it's opening down. You turn it to the left, turn to the right, you go down, and you see there's sometimes the angle is bigger, and this is smaller, sometimes it's really big, sometimes it's super small. So how are we gonna measure that? How are we gonna measure the angle? It's like you want to measure the weight of an object. Now we want to measure the angle. It's like let's say they want to measure it's like the angle between angle A right here, or you want to measure the angle between the two walls. Okay, how you gonna measure that? How you measure that? So on the second part of our video here, ooh, okay, we talked about measuring angle, and every time we measure something, we must have unit, right? For example, you want to measure the weight of the object. The unit is going to be kilogram, pounds, ounces. You want to measure the volume, be the what is it? Could be gallon, could be millimeter cube, centimeter cube, meter cube, something like that. Okay, so you want to measure the angle. Of course, we must have unit, and there are two units. The first unit is degree. And the second one we call the radian. And of course, two of them are related to each other. We can convert from one to another. Then this is also a tool to measure angle. We can use something we call a protractor. But every time you use a protractor, we measure the angle in degree. I never seen any protractor that measure in radian unit, guys. But before we talk about that, let's go through the first type unit. So the first type unit is the angle. Oh, I'm sorry, is the degree. It's the degree. Degree. Okay, degree. And inside the degree, they have the minute and they have the second. We're gonna talk about it. We're gonna give you the example. Um, that we call the decimal degree, and we call DMS, the degree, minutes, and second. Okay, but we're gonna talk about that. Okay, but let's have first degree. The degree is one of the unit to measure angle, and the symbol for the degree is usually they write the little circle um, on the upper right corner of the number. Let's say I have the angle that 30 degrees. 30 degree. 30 degree. Okay. You see the upper right corner, the little circle here. I say this is a 30 degree. Maybe some of you are like, how am I imagine 30 degree look like? I mean, so you had to buy the protractor, the protractor to help you to visualize how big the 30 degree is, or 180 degree. Of course, we're gonna go through that special degree. For example, 130, 90, but 30 degree maybe to some of you kind of hard for you to visualize. For example, I say the angle 25 degree, you will like, okay, what 25 degree look like? So you had to buy the protractor in order for you to visualize how big it is or how small it is. Okay. And because you see that when the terminal side is rotated, okay, terminal side is rotated, and it rotate. let's say at the beginning. Let's say at the beginning. Okay. Let's say at the beginning, both of the side, the initial side and the terminal side. Let's say I have both of the side is on positive x-axis. Okay, it's overlap each other. And now the terminal side start moving, rotating. The initial side still there, but the terminal side is moving. And then moving the whole, and move from here, go back down to initial side. They moving the whole circle, and make it a whole circle. When I move the whole circle, look at it, say that something like this, and move from here to here, and go back to the initial position. When I move the whole circle, we can say that the terminal side make one revolution. The terminal side make one revolution, one REV, one revolution. And one revolution is equal to 360 degrees. Remember that. Okay? One revolution is 360 degrees. So it means what? It means if you just move 1/3 or 1/4 of the revolution, 1/4 revolution means 360 degrees divided by 4, right? Divided by 4, then we have 90 degrees. 90 degrees right here. 90 degrees right here. So in this case, the 90 degree, this is what it look like. Again, I'm trying to make a very detailed video for you to understand. So let's say the initial side like that, and the terminal side is like over here. So this is a 90 degree, okay? And if it just, oh, I think I messed up with the way I write it. 1/4 revolution. And let's say I make it a half a revolution. Half a revolution means 360 degree divided by 2, right? We have 180 degree. So in that case, what we have? Okay, there's something like this. I have a terminal side. Initial side still over here. Initial side never changed. Now the terminal side this way, right? We're going to rotate like that. Rotate like this, right? Okay. And over here, this is positive. The positive 180. So, but you know that 1/2 of revolution is just half of the semicircle. It's half of the circle, right? Give you 180 degree. We are talking about a positive now. If we move this one, it becomes negative 180 degree. Okay. And you do the same way if you want to find a part of the revolution. If you want to find 3/4, okay, 3/4. Oh, oops. You want to find 3/4 revolution. So when you have a 3/4 of 360 degree, put into the calculator, give you 270 degree. So in that case, you can have the angle go like this. Huh? Okay. So I have something like this, and it's still moving. It's still moving like this, but the initial side is this way. But now you're gonna move this way. Okay, okay. So we have a terminal side this way. So you see it over here. It's over here. So this is 180. It's 180 degree. This is 270 like that. So 270 like that. Okay. And you can find a part of the revolution easily by just multiply the fraction. Just multiply by the fraction you want to. Okay. But thing is this, every time you move the terminal side, you create a very special angle, and this special angle they have a name. For example, like this angle right here is the 90 angle right here. We call this angle is right angle. It's right angle. And the flat one right here, we call that a flat angle, the 180 degree for the flat angle. Okay, and if it is smaller than 90 degree, let's say that I have a coordinate system like this. Okay, I have a terminal side. Okay, oh, I'm sorry, initial side and terminal side like this. So you know the terminal side right now is smaller than 90 degree, right? Smaller than 90 degree. So we have this angle right here. We call that acute angle. Acute angle. So acute angle is the angle that's less than 90 degree. Okay, less than 90 degree. And if it's bigger than 90 degrees, what is that called? Anyone remember? I hope some of you remember, Scott. Uh, there you go. And we have something over here. Okay, so I have an initial. Again, we have an initial side over here. Initial side, and we have the terminal side go this way. Okay, it's still positive, right? It's still positive. So this is bigger than 90 because we know 90 is right over here, the positive y-axis. So bigger than this one, we call that obtuse angle. Obtuse angle. So the obtuse angle is between 0 and, so I'm going to angle A, okay? Between 0 and 180 degree, okay? Okay. Okay, so there's a couple terminology here you want to know. Of course, there are more, but I'm sure that this four thing, different type of angle here, you guys already know this. But other than that, we have something we call that complementary angle. Well, the complementary angle is more like a position. Think about it. You have two angle. We have two angle. Okay, let's say I have something like this. I think you have the first angle like this. Terminal side like that. Okay, and the second angle. You see the complementary they share the same terminal side. So the second angle like this, second ray like this. So I have the first angle. Okay, and I have the second angle. So I have two different angles right here. Angle. I'm gonna call angle 1, angle 2. And if you go ahead and add them up, okay, you go ahead and add them. So let's say add angle 1 and you add angle 2. And if it is 90 degrees, so we can say that angle 1 and angle 2 are complementary to each other. Complementary. So you know that complementary, the sum will be 90. Okay, but actually the further meaning of complementary could be like this: as long as the sum equal 90, then the complementary doesn't have to share the same terminal side. Doesn't have to share the same side. So because if it's two angles share the same side, actually we call the adjacent angle. So I can show angle 1 and angle 2 here. We call the adjacent angle. Angle 1, angle 2 is adjacent angle. Okay, adjacent angle. Adjacent angle. Now, what if the sum is 100? If there are two angles and the sum is 180, what happens? How we call it? So let's say I have an angle like this. Okay, I have two angles. I'm going to angle 1. I have another angle. I'm going to angle 2. And this angle, add them up. You see that add up angle 1 plus angle 2 over here to give you 180 degrees. And you see that with the 180 degrees, then we call this supplementary angle. Okay. And if you notice, you see that they also share the same side, right? So this plus some supplementary angle, also adjacent angle is adjacent. It's adjacent angle. Okay. So but again, it doesn't have to share the same side, because if it share the same side, we call it supplementary and adjacent angle. But it doesn't. If it doesn't share the same side, doesn't share the same ray, then we just call it supplementary, or we call it complementary. Depends on the sum. But if it share the same side, we call that adjacent angle. Okay. Now let's go further into the degree unit over here. Actually, I said before, the degree unit can be categorized into two different forms. Okay, two different forms. The first form, let's say, sorry, I think I'm gonna have to ask my mom to move to her rooms. Okay, now the second type of unit for angle is, last time over here we talked about degree, right? The second one is radian. Of course, we can convert between radian between radian and degree too. And this is what you need to know, the relation between radian and degree. So radian, okay, 180 degree is equal pi radian, So for any, okay, for any angle, and at the end the value that has pi, it means that it's in radian unit form, okay, and 180 degrees is pi radian. And think about it, 90 degrees would be what? Would be pi over 2, right? Because half, right? So 90 degree will be pi over 2 radian, and so on, right? Now, what if you have like a decimal number, decimal degree, the DD? How are we going to convert to radian? Very easy, very easy. Now, in order to convert it, you're going to use this relation. Let's say I want to convert like 1.45 degree, and I want to convert it to radian unit. How are we gonna do that? Oh, very easy, guy. All you have to do is just set a proportion. So this is what you have to do. You just go ahead and write a relationship, and you set a proportion. So over here, you're gonna set a proportion. 31.45. We got a proportion. So make sure that you match up the degree, the unit. How many radian here? So this is what I'm gonna call x. Remember the pre-algebra course we learned, college algebra. This is pre-algebra. So this is how you do. So we're gonna go ahead and solve for x. So we do cross multiply. So we're gonna have 180 times x equal pi times 31.45 degree. So all you have to do is pi times 31.45 degree, you divide it by 180 degrees. So let's see how many pi we have, okay? So let's go ahead and use the calculator really quick over here. So we have 31.45, you divide by 180, which is give you 0.172 pi radian. And if you're going to convert the pi, you have to multiply by pi number 3.14. Okay. Okay. Multiply by pi, which is end up. Go ahead and use calculator, okay? 1.549 radian. There you go. You can leave the pi, or you can go ahead and multiply by 3.14 and give you radian. So that's how you convert between radian and degree. And in order to convert from radian to degree, or degree to radian, you're gonna set up proportion, and you do the same way as you do. Okay. 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 I don't know if you can hear the noise in the back or not, but again, if you hear it, I'm sorry. Sorry for the disruption. I asked my mom to move to her room so that we can be more isolated. So where we stop at? We're talking about two different form of the degree unit, right? Now, the first form, the first form of the degree unit, we call that the decimal degree. We call that DD form, decimal degree. Okay, decimal degree. So in the default, so basically, in this form, it's just a decimal number. That's why decimal degree means decimal number. And this and the second form, I'm gonna write over here. We call that degree minute, and second. So then we call that DMS. Okay. So we can convert from one form to another form easily. Let me give you example. Let's say over here in the decimal degree, I have this example. Let's say I have 386 point decimal, right? 25 degrees. So this is in decimal form, just decimal number. That's all. And over here, I have 74 degree, 8 minute and 14 seconds. So minute, we use the param. What's that called? I think it's called a, a, a truffle, apostrophe, something like that. I forgot the name. And but I would just say the param. And this is a 14 double param. That's all. I think I got a apostrophe. I think that is the correct name for that. Apostrophe, something like that. Okay. Now I'm going to go ahead and try to convert the decimal form to degree. It's very easy. In order to convert it, all you have to do is just the first step, just go ahead and split up the whole number and the decimal part. Okay. And you want to go ahead and convert it to the minute. All you have to do is you just put 0.25. Okay. You multiply by 60. Okay. Let's see what I give you. 0.25 times 6. Does it give you 15, right? Yeah. So we end up with 36 degree and 15 minutes. 15 minutes. Oh, you see that? Because we multiply them up, it'll give you a very beautiful whole number 15. So we don't have to convert it to second anymore. Because if you can go ahead and convert to second if you have more decimals. So let's say okay, instead of 15, they have 15.33. Then you have to multiply by 0.33. You multiply by 60 again. In order to have in second. Okay. You keep multiply by 60 in order to have DMS. Now for DMS, so instead of doing multiplication, we can do division. So we have 74, and you added a divided by 60 because 1 minute is 60 seconds, and 1 minute is 1 hour 60 seconds, 60 minutes, 60 minutes, and there's 1 hour. Give you 36 seconds. Okay, so you do division instead of multiplication, and now you combine all of them. Combine all of them, and what will give you 74.137 degree. Okay, so that's how you do that. Okay. Now let me give you another example when you have to multiply by another 60 here. As I have 34.17 degree. So let's go ahead and split them up. We're gonna have 34 and split up 0.817. Now you have 34 degree. Take 0.817, you multiply by 60, they give you minute, which is give you, I put it to the calculator, guys. So 1.8 7 and 60. Oh, right here. Look at this. This is give you 49.02. You see they have a decimal place in the back. Now, because they have decimal place over here, you have to continue. So they get 34 degree 49 seconds. And now you're gonna take 102. You multiply by 60 again. That give you 34. 49 minutes. 0.02 multiplied by 60 to give you 1.2. 1.2. 1.2 second. And you go ahead and write them up. Give you 34 degree, 45, 49 minutes, and 1 second. 1.2 you write up. Okay. All right. Now, after we already know how to convert, let's see how we do the operation of that. We can go ahead and multiply. We can do adding, subtraction. Let's see if we can do that. Multiply a different story. Okay, we don't deal with multiplication. Multiplication we just go ahead and convert to dm, dd. I'm sorry. To multiply, we cannot leave dms. But for dms, we can add or subtract. Let's say I have 51 degree, 29 minutes, and I want to add it to 32 degree and 46 degree. That's 46 minutes. So all you have to do is just add them up, and I give you 83 degree and 75 minutes. Okay, 75 minutes. 75 minutes. Now, if you go ahead and convert it, you go ahead and continue convert it up. So let's see what I give you. That's a very good thing to convert this. It means 83 degree, 75 minutes. 75 minutes. Think about it. 75 minutes is like more than an hour, right? So 16 minutes is an hour, right? 16 minutes is an hour. Okay, so 75 basically is 1 hour, right? 1 hour, 1 hour, 1 hour, 1 hour, right? And 15 minutes, right? So 1 hour you can write at 1 degree. Very good information, right? 1 hour is 1 degree. And you add it, so you 1 hour and 15 minutes, right? Because it's 75, so 1 hour and 1 degree, 15 minutes. So they make it 1 degree, 84 degree, and 15 minutes. Ooh, kind of very interesting information over here, right? So 1 hour is 1 degree. Remember that. Okay. Now, how about subtraction? How I do subtraction? Let's say I have a 90 degree, and I want to subtract it by 73 degree and 12 minutes. Well, look like the degree is good to do subtraction. It's easily, but now for the 12 minutes, how are we gonna do that subtraction? So, but in order to subtract the minute over here, we must have the minute, right? But over here we don't have anything. So what we gonna do here? Very easy. Because we know that 1 degree means 1 hour, 60 minutes. So I can write this is 89 degree, 60 minutes, right? Because 89 is 90 is 89 plus 1 degree, 1 degree. It means 1 hour. 1 hour is 60 minutes. Remember that, okay? It's 12 minutes. So now we can go ahead and subtract it, which is give you 16 degree and 48 minutes. So from this problem here, this is what we can conclude. We can conclude that 1 degree is 1 hour. 1 degree is 1 hour. Interesting. Interesting, huh? Interesting, very interesting. Okay. All right. So let's say so far we talked about the definition, how to measure, some terminology. Now let's go back to the first page. So you see over here, if the terminal side, you see that this position at 90 degree to the 70 degree or flat angle, this position here, we also have name for that. We also have the name for that position. That position we call that quadrangle, quadrangle angle, quadrangle position. Okay, so on the third part of our lecture, the small terminologies. We're going to talk about more special. I'm going to just go ahead and put how we're going to put the title for this third Roman note here. I just go ahead and put what did I put last time? I put angle, measuring angle, special position. I'm going to put special position angle. Okay. So the first one we have a quadrangle position of quadrangle angle. So if it the terminal side 90, 180 or 270, that position or 0, that position will be quadrangle position. So think about it, you have the coordinate system like this. Okay. And the first position is when you have terminal side. So this is 0 degree. Terminal side and initial side is on the positive axis. So this is the position of quadrangle. It's one of them. Or it could be like this. Trying to move over here. See how I'm gonna move it. Here you go. Okay. Now the second position. The second position is the terminal side. Okay. Initial side still here, but the terminal side here. So it's 90 degree angle. This is quadrangle position. Or terminal side here. The initial side here, but the terminal side here. This is 180 degree. This is also quadrangle position. So quadrangle position actually is the rotation of the terminal side at 4 different corners of the coordinate system, right? So I have this one from here. And right here. Try to be perfect, guy. Right here. 270. So we have 4 triangle positions. Remember that, okay? Other than that, if the terminal side, is in the first quadrant of the coordinate system, think about this. We got to create the acute angle, right? But that acute angle, we call that acute angle. We call the reference angle. So what is reference angle? So reference angle is created by terminal side and the x-axis and must be acute. It must be acute. Okay, it must be acute. For example, like I have two positions we can draw it for you. The first position, this is a reference angle. First position, we have a terminal initial side here, and this terminal side here. You see, this is acute angle. So if the angle created by x-axis and the terminal side between 0 and 90, then that's reference angle. So this I'm going to call the angle theta, and over here the angle between 0 and 90 degree. Right? All the superposition you can have like this. Reference angle is very important, okay? Because later on we're going to use the reference angle to calculate trigonometry ratio. So the initial side is still here. Okay. But now the terminal side this way. Okay. So the reference angle is created by this axis. So we have, you see the reference is created by terminal side and the x-axis. But in this case, the x-axis and the initial side is overlapping. Now what if in this case, the x-axis go this way, right? The x-axis is this way, now this axis this way. So the terminals, the reference angle must be right over here, right? Because it cannot be this one, because if it is this one, then it's bigger than 90 degrees. So the reference angle must be right over here, it's smaller. So first of all, two conditions to be called reference angle. First of all, the angle must be between 0 and 90. And secondly, it created by terminal side. Created by terminal side. In x-axis. Okay, terminal side. Positive x-axis sometimes, in this case, the first case, the positive axis, the second case is negative axis. But as I create between the terminal side and the x-axis will be fine. It must be between 0 and 90. It must be between. Satisfy those two conditions, then we call it reference angle. Okay. Now, another special position angle I want to mention is coterminal angle. Coterminal. So what is coterminal? Coterminal. So this is the definition. If you have two angles and sharing sharing the same initial and terminal side. It's sharing the initial side and terminal side. Then it is coterminal angle. And the second condition is that their measure must be differ by a multiple of 360 degrees. Okay, let me give you an example of coterminal angle. Let's say I have something like this. I have the first angle. Okay. I'm using purple. Let's say the first angle over here, I have an initial side and terminal side, and this is 30 degrees. Okay, positive. So this is 30 degrees. Now I go ahead and draw another angle that coterminal to this angle. as long as we share the same initial side and terminal side, right? So the coterminal angle of this will be of 30 degrees will be this. It will be from here, share the term, share the initial, and share the terminal. So what is that? The whole revolution, right? So 30 degree and 360 degree is actually coterminal. They are coterminal. They are coterminal. Of course, they have a lot of coterminal. Think about it. I can go ahead and draw another coterminal with 30 degree. Let's say I use different color right here. Let's say I want to use. See, this color is good. Okay, this color is good. I find another coterminal. Let's say as long as we have the same, we have the same initial side and terminal side, then it's okay. Let's say I have the terminal. The coterminal will be this one. How about let's start with initial side. Oh, I think I messed up. Let's see, mess up with. Sorry, I can't. Oh, how am I gonna go ahead? I cannot go back. So I just go ahead and draw that again. Okay. Now let's go ahead and draw another coterminal. Okay. Use different color. Now the coterminal will be this. Let's start with initial side and with the same terminal side. Here you go. But this one go clockwise because the clockwise will be negative, right? So the coterminal angle we have over here will be 30 degree and negative. Negative what? Negative 333, right? You got the whole thing. The whole thing is 360. The whole thing is 360. The 30, so the left will be negative 330, right? Because it's negative, because it's counterclockwise. Oh, it could be clockwise. So they are also coterminal. And there are many coterminals. Just think about it. As long as you draw the start with initial side, and you end up with this same terminal side that we have a bunch of different coterminal angle. Okay, very important too, because in the homework they can ask you to find the coterminal, but they don't give you the picture. They give you the picture, we just go ahead and draw it. Okay. Okay. But some of you really good, you don't need a picture. Let's say I have something like this. What if I draw five coterminal of 908 degree. Okay, he was like, okay, how are we gonna find coterminal? Is it okay? Of course, you're not gonna go ahead and draw the picture. You can, but think about it, 980 degree. How many revolution? How many revolution is it? Very easy, okay? Because one revolution is 260 degrees. We already learned that. So you just take 908, you divide by 360, then you end up with around around 2.5 revolution. So about 2 revolution. If you think about 908, you subtract 908, you subtract by 360 is 1 revolution, right? And you subtract again 360, give you 180. So you have 2 revolution. Okay, because you can try to give you 1 plus 188 degree, right? So 908 is 2 revolution plus 188 plus 188. So what is going to be? Going to be the coterminal. Very easy, right here. The terminal right here. So 188 is coterminal. 188 is coterminal. Okay. Actually, the way you write it, so that the match of the definition will be like this. Will be -8. You subtract 2, 360 degrees. Give you 180. Okay, so 180 is one of the coterminal, and say that that is the only one because you can find more coterminal of 980 degree easily. Over here, they just ask you to find the positive coterminal. It so depends on they ask you to find the positive or negative. So in this case, I have the positive coterminal. So they ask you to find coterminal. You just need to find positive one or negative one. So sometimes the question is really specify like which one they ask, negative or positive coterminal. So in that case, you have to draw the picture because maybe it is hard for you to see the negative coterminal. But you can imagine, think about it. You have 2 revolutions and another 188, right? So you go ahead and draw the picture. You have think about it. You have like this. You have 1 revolution, 2 revolution, right? 2 revolution already. 1 circle, 2 circle. But you have another 180. So 188 is the add more. This is 180 right here. So 88 a little bit right here. Okay, so this is right here. So the 180, this is 8 more degree right here. 8 more degree right here. I don't know, you can see the 8 more degree right here. So I can find the coterminal angle or negative value very easily. But I'm gonna go ahead and draw here. So the negative coterminal angle will be this one. So you just take 180 180 minus 8. So negative 172. Negative 172 is coterminal. Negative coterminal. See? That is. You draw the picture, it should be fine. Okay. So that is all for section 5.1. Just one of definition. The homework should be simple right now. But if you have any question, please go ahead and send me the message to Canvas inbox. Okay. I'll try to reply really fast. Really fast. Okay, I'll be seeing you next time in the next video.